Alright, my goal is to briefly go over hill climbing and local search. I'm going to quickly go over hill climbing, and then I'll spend a little bit more time on local search. This is based on the examples from the discussion, and whether or not it's representative of the actual concepts themselves, I don't know, but for helping people understand the general basis of what's going on. Alright? So hill climbing. Basically, hill climbing says that it wants to move to the closest local maximum. So it'll iterate one by one between each of its neighbors. It'll check the neighbor before and the neighbor after. And if that maximum changes between all three of those points, so -1 at that point and then +1, if the maximum changes, then it'll go to that maximum and then repeat. So, for example, at x is equal to 1, we can see that it has only one neighbor, x is equal to 2. It'll go up because x is equal to 2 has a higher maximum. At that point, you'll repeat again. You'll check both neighbors, x is equal to 1 and x is equal to 3, relative to your new point. You'll see that x is equal to 3 is going to be higher, and you'll move to 3. Same thing, check 2, check 4, you'll see 4 is higher, move to 4. Then you'll check your next neighbors, check 3 and check 5, and neither of those neighbors are going to be higher, therefore your maximum value is going to be at 4, and that is when the hill climbing iteration will end. You'll generally be moving in the same direction, because if you try to go back, then you're kind of just going to be stuck in a loop, so you're never really going to be going and turning something back off or going backwards in a graph. So for the example shown in the discussion, the general rules were that the neighbors were defined as x plus 1 and x minus 1, and that you're checking for the maximum value at the integer point. So for the example given an initial state at x is equal to 2, the hill climbing will finally reach a y value of 2, because you're checking both of the neighbors. You're checking at -1 at x is equal to 1 and +1 at x is equal to 3. You'll see that x is equal to 1 has the highest neighbor. You'll iterate again just to double check and make sure that there's no more things that you can iterate to at x is equal to 0, at x is equal to 2. You'll see that they both go down, so then your final y value will be 2. Then, let's say given an initial state at x is equal to 3, hill climbing will finally reach a y value of what? So first you'll iterate and check both of the neighbors at x is equal to 2, which is 0, and then x is equal to 4. X is equal to 4, you can see that the y level is 1, so you'll move to x is equal to 4, and then you'll iterate again. You'll check x is equal to 3, which it's not the case, and x is equal to 5. So you'll check x is equal to 5, so you'll see that it goes higher and it goes to 3, so then you'll move to 5. You'll check 5, then you'll check its neighbors, x is equal to 4, it goes down, x is equal to 6, it goes down. You'll stop the iterations at 5, and you'll see that it has a y of 3. Same with x is equal to 4. In this state, you can tell that it is going to be x is equal to 3 based off of what we had done previously, because you'll just check the neighbors 3 and 5, go to 5, check 4 and 6, stays at 5, so it'll be 3 again. Same thing with 6, you'll check 5 and you'll check 7. Because both of them go up, you'll go to the higher value, which will be 5, and because it's going to be 5, you know that it'll terminate at 5, so at x is equal to 6, the y value will be 3. At x is equal to 7, you'll check x is equal to 6, it goes down, so it can't be that, and x is equal to 8. X is equal to 8 is the same as 7, so the maximum does not change. Therefore, you're going to stay at that same y value at x is equal to 7. So the y value will be 2. And then finally, at x is equal to 8, you check 7, it doesn't change. You'll check 9, it does change, and it goes to y is equal to 7. You'll check x is equal to 9 again, check 8, check 10, see that it both goes down, and you'll be going at y of value of 7. Alright, that's just a quick rundown of this stuff, of hill climbing. Next is local search. So for the problems that they gave us the 3 SAT problem. So given a set of clauses, utilize 3 iterations of the hill climbing method, or hill climbing algorithm, to maximize or turn all of the clauses true. So our goal is to turn all of these clauses to be true statements. So we have x1, and using the table over here, x1 or not x2 or not x3. We want that one to be true, we want this one to be true, and we want this one to be true. So we want to, if needed, change any of these Boolean states. That way it reflects and makes all of these clauses true. But we also want to minimize the number of changes that we make. So we'll check and compare each one on the next screen just to show the Boolean changes that we have to make. It'll make more sense when I run through the example really quickly. So the steps that you do to solve it is you evaluate the initial assignment. So the initial assignment was the x1 or not x2 or x3. So at x1 you can see that it is true, so it is true here. At not x2 we can see that it is false for x2, so not x2 will make that true because that's a double negative, and that'll make it true. And then x3 is true, so that'll become true. Because it is an OR statement, if any of these are going to be true, then that makes the entire clause true. So true, that becomes true. Same with the second clause. As you can see, it's a anti-Boolean, so it's false, 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 and it results in the entire statement being false. For the third clause, x1 or x2 or not x3, this will be true, false, false. Because it is an OR statement, you have all of these like being different symbols, but because at least one is true, that makes the entire clause true. So the goal is to satisfy the final clause by making this a true statement and by changing the least amount. So then you evaluate each variable at a time by flipping the Boolean that they were initially. So if you flip x1, that means that you're making x1 false initially. So then this will become false, and then you'll reevaluate. So when you reevaluate, you can see that clause 1 becomes false, true, true, at least one state true, so it's true, true, false, false, that becomes true. But then for clause 3, you see false, false, false. So the same amount is still totally satisfied, but based on the current assignment and the change that you made to x1. Then you'll flip x2, you'll change that one to true. And you'll do the same process, true, false, true, that's true, false, true, false, that's still going to be true, 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 false, that's going to be true, and you'll satisfy all three clauses. Just to make sure, you'll run through the same one, and you'll flip x3, you'll get true, 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 and it also satisfies three clauses. Afterwards, you'll go to step 3. Choose the variable flip that maximizes the number of satisfied clauses. If 2 or more variables yield the same maximum increase, flip the alphabetical first one. In this case, x2 is alphabetically first compared to x3. Even though they both had the same maximum increase, we are going to flip x2. And because all of them have been satisfied, that is all we have to do. So the only thing we have to do is flip x2, and your final will be x1 is equal to true, x2 is equal to true, and x3 is equal to true. Alright, now, this was the problem that was shown at the very end of the discussion that took a while, but basically it's the same thing. You're given a bunch of variables with different Boolean or a bunch of values with different Boolean variables, and you're given the 3 SAT formula. So it's not x2 or not x3 or x4. Next is x1 or x4 or x7, then x1 or not x5 or x6. So then it's going to ask you again, perform 3 iterations of the hill climbing algorithm, and just follow those same steps. The question they ask is what is the value of x1, x3, or x5, but after you're done evaluating it, then you'll have all of the new values. So let's start. The first step is to evaluate. So first is going to be not x2 or not x3 or x4. So as we can see, not x2 is going to be false because that's a double negative, or that is just a true turning to a negative, or x3 is going to be false again, and x4 is going to be false. So because of all this, this will become a false statement. Next is x1, or x4 or x7. x1 is false, x4 is false, and x7 is false, based off of the initial Boolean values that we were given. So because all of these are false, this is a false statement, or a false clause. Then finally the same thing, x1 is false, not x5, so true, not, that means that it is not true, so false, and x6 is false. So then this is a false clause. If that makes sense, that's great. If not, feel free to just rewind or go back. I did kind of blitz through this, but basically you're just checking it against the symbols using the logical operators, and then if any of these become true, then this becomes a true statement because all of them are ORs. Alright, step 2, you flip one variable at a time and evaluate the neighbors. So, just like before with the previous example, you're gonna have to flip each individual one and reevaluate each time. So, for x1, you'll flip this to true, and you'll evaluate. So clause 1 becomes still false because x1 is not included, but it is included in clause 2 and clause 3, making those both true. So then you satisfy at least 2 of the clauses. Afterwards, you'll move back to x2, and you'll only change x2 into false. You'll check again, you'll see true, false, 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 and you'll satisfy 1. Same with x3 and x4. Here you'll see it satisfies 2 because this changes to true and this changes to true. So clause 1 and clause 2 are going to be satisfied, and clause 3 is going to be untouched because x4 is not in there. Then for clarity's sake, or for just keeping track of time, x5, x6, x7 have just kept the same. They only satisfy 1 because they're all only in 1 each. Alright. Next, you'll choose one variable to flip permanently. If 2 or more variables yield the same maximum increase, flip the alphabetical first one. So, just like before, because x1 came first and it satisfies 2, then you will be flipping x1. Oh, let me recircle that better. Let me not do that. Please, guys. But yeah, no, you're just flipping x1. Because x4 comes alphabetically after. Then you'll repeat at least 2 more times, because according to the instructions, they wanted us to repeat it 3 times. So remember, the Boolean chosen will stay flipped. And because we haven't satisfied all 3 of them, we still have to keep going. So now the new Boolean is going to be x1 is equal to true, x2 is equal to true, x3 is equal to true, and so on and so forth. I didn't have a pointer, but basically x1 is the only thing that changes, and it changes to true as you reevaluate. So then you reevaluate again. As you can see, if you flip x2, you'll change the first variable to true, and because it stays the same for the next upcoming iterations, clause 2 and clause 3 become true. So after you flip x2, you satisfy all 3 of the clauses. You'll go again for x3, which satisfies 3, x4 satisfies 3, 5, 6, 7 satisfy 1 each. So again, after you take it, you'll check which one satisfies the most, x2, x3, x4. You will then choose the one that comes back alphabetically, and that will be x2. And finally, you flip x2, and afterwards all of the clauses are satisfied, so you will end the loop. And the final answer will be x1 is equal to true, x2 is equal to false, true, false, false. That is my understanding of 3 SAT problems with the logic stuff. let me know if you have any questions.